But first, let's see what there is. So JavaScript is awesome. I mean, you have no explicit types. Variables may be undefined. You have repetition, repetition, repetition if you're using HTML. You have no templates. That is extremely awesome. You have no compile time function execution, because who needs that anyway? And the best thing is you don't even have a compile time. And hopefully right now you're thinking this: what is this guy doing here? Well, maybe Andre Walt and the others on the Dconf committee screwed up, but actually they didn't really. Because when I saw this, that I had to use JavaScript, I was like, no way, never. So what you actually want to have is that you want to have a type in the database that has types, has the right names, and you also want to have this type in the server, your backend, and you also want to have this in the front end. And that sort of presents a small problem there. This basically leads to that everything should be dry. So you don't actually want to repeat the type over and over again because, well, you misspell and you're screwed, basically. Additionally, you want to have performance. And this sort of is not specific to D or JavaScript or everything in between. But, I mean, again, it's an important goal here. And especially you want to get things done. So having to keep multiple definitions of types synchronized by hand between different technologies is just a pain. And that is definitely not dry and definitely doesn't help you get things done. So before we can talk about the actual front-end part, we need to talk a little bit about vibe and especially diet, because we don't want to write HTML. So what is vibe? Vibe is basically a very powerful library that helps you with everything asynchronous, especially when it comes to I/O and web. So it uses fibers and threads, and there's like a mapping from fibers to threads. There's this yield command that luckily you actually don't really have to use that often, and it does asynchronous I/O for you without your intervention. I mean, you don't really see it. And that's actually one of the best parts about it. You don't see it. You just write your function, implement your function, call maybe your database, return from your function, and you don't even see the asynchronously in your program, but it's there and it works. So that's extremely awesome. Additionally, you have a binding to a couple of databases. MySQL is not really built in, but the package on code.dlong.org is so good that you just include the dependency and you are happy. On top of that, there's a web interface generator, which I didn't really use, but there's also a REST interface generator, and this thing is really awesome. I mean, that makes using or creating REST interfaces so easy that there's actually no excuse not to use it. And we're going to talk about this for a little while and then see how everything fits together there. So I have this awesome API, which I defined in an interface, which gives me the weather. And the function definition, you can't see my laser pointer, awesome, is that there's a URL which you can do a GET request on, which is called weather, and you get a JSON response with the text and the temperature, and there are some values inside. And you basically write this or implement this function in something like this. So you have a class that is implementing the interface, and then you have your function, which is returning weather with some text out of the weather string array there, and the temperature, which is just a random number between -10 and 30. So that's basically everything you have to do to create a REST interface. And then, of course, you have to do a little bit of scaffolding and stuffing everything together. So there's a router, of course. And there you can also define static templates. And these static templates are basically just template functions where you give a string to a file which contains diet source, which gets translated to HTML, to something you can call and get HTML back. But back to our REST interface. So we stick, like on the last line, we stick our implementation of my API implementation and some settings into the router, and then we can call weather on our host, and we have this awesome weather interface, which returns us a random weather. Just for completion, the weather is basically just a destruct with a string and a double, and that's it. and it gets serialized to JSON, and on the other side, we can then use the JSON we get back. So the other side, as I said, I don't want to write JavaScript, because as soon as you have undefined is not a function once a day, it's like, hell, please get me out of here. So other people actually had the same problem, and what they said is, well, let's invent a language on top of JavaScript. And TypeScript is one of them, but this sort of translates to all of them. So if you are into Dart or whatever is out there, that's basically the same thing. And what they did is, well, they said, types are awesome. JavaScript doesn't have types, so we're going to add types. And they did this in a, or at least TypeScript did this here in an interesting way. So what you can do is you can define an interface, like here, weather, and you should probably be able to read this. There's like a text in it and a temperature in it, and you define the types after a colon. And now this allows you to say, I have this JSON object here, and I have annotated it in such a way that I know it's of type weather. And if you do this in all the places of your program where this JSON object is passed around, you sort of get a compile error saying if you're trying to use something out of this JSON object that isn't actually defined in the weather interface. So you get sort of a compile time error saying whatever you're trying to use there, it's not in the interface, so please fix that. Additionally, you usually want to use JavaScript single-page application framework to build your single-page applications, because handling the DOM on your own is an immense waste of time, because people have already built libraries for it, which are actually good, and one of them is AngularJS. And as the name already implies, AngularJS is actually a JavaScript library, so sort of bad. But the good thing is TypeScript. The good thing is TypeScript is non-intrusive, so every JavaScript program is also a valid TypeScript program. So if you have a legacy JavaScript code base, you could start adding types gradually, and at some point have like everything typed. And even better, there's a GitHub project called Definitive Types, and what they did, they actually did this for basically all JavaScript libraries out there. So you just include that, and then suddenly AngularJS, which is a JavaScript library, to repeat, has types magically, and it works. So the other thing Angular has is you have sort of to define what is in the page you're displaying, and what is that? That is called a scope. And there, with our help of interfaces, we can actually say in our scope, which is here called main scope, there's like only one object, and that is a weather, or that object is called weather, and is of type interface weather. So we know now that the page we're displaying is only displaying one weather object, and we can assign values to this or to this scope, and the assigned values will then be displayed. And then we need a little bit more of scaffolding, and that is like what they call a controller, which is basically the point where the displaying is starting to interact with the backend. And here we call, in the constructor, we call the method weather, and what that is we're going to see in a second. So weather is a method which you couldn't really have in like the old versions of JavaScript anyway, because it didn't really support classes, but they simply implemented classes while they're at it, and everybody's happy. And here we use HTTP and the GET to actually call our API created with Vibe. And the cool thing is, as this is asynchronously, we get something bad at random time. And then they implemented a Lambda syntax, basically, that looks pretty similar to what D has. So we get data back of type weather, and we assign this to the scope. So basically what we now have is, as long as we keep the TypeScript interface of our weather struct in sync with our dstruct of type weather, we know that whatever we access inside or on the front-end part is there and is of the correct type. So extremely awesome. We retained the type information from the backend to the front end. And now, as I said, I didn't really like to write HTML because HTML is just stupid repetition. We have Diet, and what Diet is, I mean, if you look at it, it's basically Python for HTML. You have like intention to give you the structure which you which you usually do by opening and closing HTML tags or XML tags. And here you basically do the same thing with indentation. And the actually really cool thing is you see this minus here in the JavaScript. And that is actually a function we wrote in Diet, which then gets extended to a script tag where the name is passed in. So even less repetition, we can write functions now. So, I mean, if it gets any drier than this, please tell me. And just for completion, there's also this awesome shortcut. If you write a dot in front of it, you automatically get a div container, because this is something you really have to do all the time, and especially if you start to use like CSS to make stuff pretty, divs are an important part of it. And the container there is just the name of the class assigned to that div container. And here we can actually see what we are doing with our weather. So there are two paragraphs. One is displaying the text of the weather, and the other one is displaying the temperature. And additionally, we have a button there, which is calling our weather method inside of our controller. And now it's time for live demo, which hopefully works. So let me... just to show that it actually works. So it looks shitty, I know, but it works. So if we press the button, we have a round trip to the server, getting a new weather and displaying it here. So I didn't lie, it actually works. Okay. So the important part is how we get the data from the server to the front end.
Can I ask a question?
Where are you? I can't. Yeah?
Yeah, the diet template is generated server side or client side?
Yeah. So I was sorry for not explaining this. There are two ways to get HTML templates to Angular. One is writing it in the controller itself. There you have to write actually HTML. The other way is you can give it a URL to fetch the template from. And what I'm doing is I'm writing a diet template that is available on a specific URL, which is then sent to the server. Or like the controller is asking for it on the server and then gets displayed. So yeah.
Okay, clear.
So remember the struct on the D side, and remember the interface on the TypeScript side. Where's the problem? Come again? Is it out of sync? Can you see it? Exactly. So as I said, actually managing this by hand, having both in sync, is like really stupid, because I mistyped temperature in the TypeScript interface. And that is actually something nobody should want to do, because that's just stupid work. And as Andre said, everything that can be automated should be automated. So behold, the awesome program dstructtotypescript. It's exactly what the name says. It takes destructs and converts them into TypeScript. So just to explain a little bit, the -e is sort of defining the file where to look for the struct in. Then you have the output file, which is like behind the -p, and you also then define the s, which structs out of the file you want to translate. Again, having the weather struct, and then the also common traits get or members on weather, dstructtotypescript generates a file, or actually generates a program that copies in which basically copies in everything of weather into a new file, then hooks up or then writes the for each loop for the things passed by -s, and then this writes the interface file. And this file then can be used in your build process of your front end. So you only have to write, or you only have to fix the typo in the destruct side, rebuild or rerun the program, rebuild your front end, and it's fixed everywhere. And actually, if you like use the interface wrongly at some point, you will get a compiler warning saying that the name doesn't exist anymore, and you can look up the change and be happy after all. But actually, everything is sort of still wrong. I mean, it is Captain's Day. We have fixed a really annoying problem, but still, I wasn't really happy at that point, because all we actually did was solve a very, very tiny problem. And what about the way from the server to the database, or the other way around, actually? And what happens if my colleagues decide to use Dart instead of TypeScript. I had to write a new program called dstruct-to-Dart or dstruct-to-conjure-ss or whatever. That's not really what I wanted. And additionally, how do I communicate the overall architecture of the system I was building? So I had a nice hack getting my destructs to the TypeScript side. But I mean, communicating that intention or communicating that way didn't really, I mean, there was still no way. Additionally, at some point you might write a little bit of documentation about your architecture, and that is not kept in sync with the actual code. So either you do this by hand, but I mean, doing stuff by hand is not the programmer's way, so not really cool. And one of the major problems is how do you actually communicate what you're trying to build with non-developers? I mean, if I show what I've done to you guys, you might understand, but if there's a customer saying, I want to have a fancy shop where I can click this button, he doesn't give a shit about this, actually. So how do you actually deal with this change? And this led me to sort of another quest I'm pursuing right now. So first I searched what actually is there. And of course, there's the waterfall model, but I mean, nothing ever changes there. If we screw up the initial design phase, then we're basically stuck with a crappy design and it doesn't really work. We could just start hacking. That's basically what I did. And I mean, there's no plan, there's just change. Doesn't really lend itself good to communicating the design of anything. Agile method, I would be blunt and just say that's just hacking with fancy names. Please don't kill me right now, wait after my talk is finished. So if you have then the waterfall model and maybe even add UML to it, you have like 5 or 6 diagrams which are just kill me already. So that's me, I'm basically in the middle and I need help. So before I can get help, I sort of have to say what I actually wanted to do, or actually want to do. So what we want to do is we want to speak about our system at different levels of detail. So we want to have the customer saying, yes, I want to have this button clicking there, or I want to be a person that does something with our system. He doesn't care about details. But on the same, from the same model, basically, we want to talk about finer grained detail, what actually is happening when he's clicking the button, how the data or where connections are between the different sub-modules of our project. We also want to quickly introduce people to our project. That means we actually have to have a way of iterating through the different levels of detail and show people where stuff is going and so on. Also what we want to have, I mean, I have this awesome project or program that generates me TypeScript from dstruct. But this is not really what I want. I want to have this in a more general way working for everything, or at least have the possibility to write something that then is doing the same thing for Dart or for a NoSQL database or whatever. And the best thing would be if I only had to write one description of such a system. And of course, it needs to be line-based because it needs to fit in our Git, so I can track the changes I was talking about in the beginning. And the sort of not really most important part, but a very important part of it is I want to generate as much boilerplate as possible. So I don't want to generate database access. I don't want to generate the interface classes. I don't want to generate, basically, I don't want to write anything. I want to generate everything I can. So, of course, somebody else, probably smarter than me, already thought about that, and this is like the C4 architecture by Simon Brown. And what he basically did, you can't see shit here, so there's like the first view where you have a system context. This is basically just giving you stick figures and your software system, and then you have edges between these so I'm going to get into that in a little bit detail, sorry. Then one level deeper, you have containers, and these are basically software systems or any system. And then this splits up into components, and like on the bottom layer, you actually have UML classes. So I need a little bit, you need at least a little bit of UML to actually display what you want. So on the system context level, you basically have these stick figures which are using the system. And then if you look into the software system, you have different containers. And a container, if you heard the word container from now, just think unique process ID. And that's basically a container. And these communicate in some way, not really that important. And then if you then start to look into the container, which we're going to do for the content updater, that divides into components where you would separate like different concerns of said container. And the bottom level then would be classes, but I don't really want to go into that because you all have seen UML class diagrams, which is basically what's inside of components. And it's really awesome. Just let me have a drink here. He even was so smart that he implemented the structurizer, which is basically a program that does everything you want. And it is written in Java or C#, and you use normal Java or C# code to generate the model. So it is line-based, it fits into Git. It also generates code, but the bad thing, it's only Java and .NET. So, I mean, how hard can it be? So as a good programmer, what you do is you're just going to re-implement this 2 weeks before the presentation, right? Yes. And this is actually where D comes in. So I said to myself, I'm not going to generate a new language for this, because why would I? I have D, and the compile time is so fast. Maybe later I'm going to create a language, but for the time being, no. It's actually not even a library right now, it's just an executable, but same thing. So looking at the model, like for 10 minutes, you will see that it's actually a very simple AST. You have some high-level declaration that falls or that becomes even smaller declarations, and basically an AST for a language. And the model is pretty simple. You have the world, or which is like the system context where everything is inside, and the world has actors, software, hardware systems, and then software systems, again, have containers, like think unit pid. And containers then have components which hold modules, which you would call components. And actually, I had to add something here. It also needs to hold classes, because this makes describing databases easier, but that's not really a big change. And inside of components, you have even more components if you have like substructured your program a little bit, and you have classes. And classes have members, either data members or function members. Not a big thing. And so if you can't see this, there needs to be connections between everything, and there you can just use the UML class diagram connections. So you have association, aggregation, composition, and then just dependencies. And these, if you think about it, then easily translates into the appropriate D command, like imports or stuff, and also on the TypeScript side, basically the same thing. So then actually using the Degenerator, as I call it right now, is really easy. You create a world, give it a name, then you get the world, create an actor, give it some description, get the world, create a software system, give it a name, then stick a container into your system, give it a name, assign a technology, and add components. And this continues. At some point, you then want to create links or dependencies between those components, and basically just say, world, make me a dependency with given name between the server and the backend, and then put a description to it, and so you build your model bit by bit. And as you can see, this fits nicely into a Git, and if somebody changes something, he hopefully writes a good message, what he changed, so you can track the change. And the only thing a little bit different are classes. So as said before, we want to have a data object or class to live in different technologies. And what we then have to do is add this class to different containers. And by the power of D variadic templates, we can easily say, get a new class of given name user and add this to all the components or containers. And it nicely inserts them in the right places, and we have a new class user. Getting from there, we need to add members, and members are basically just subcomponents of the class there. You can say, get me a new member variable with given ID, assign it a type here. About the types, we're going to talk a little bit or later, but but just say there's an integer type to this user ID, and now there's a little bit of interesting things we have to do. So this is actually supposed to be the ID of the user table in the MySQL database. So what we have to do is basically add the annotation that this ID is the primary key and is supposed to be auto-incremented. But as the backend technology might change, I didn't really want to create all the enums and all the special cases for all the databases I wanted to work. So I'm just using an associative array here where you can define the technology, as in this case MySQL, and then add, as the name actually says, add language-specific attributes to it. So whenever you think, oh, I invented this awesome database technology that has some sort of primary key, which is not called primary key, just add a different language-specific attribute to it and be happy. So, where was I? Now we're going to create another class to actually show what we can generate from connections between classes. And we're going to generate an address class. And we're also going to add this to all our three components. And then we're going to create an aggregation between the address to the user. So basically saying that a user has an address. And we're going to see this again later. So think about it. There's going to be a connection between the address and the user. But speaking about types real quick, a string is not always a string. So in D, it's called string. In MySQL, it's called text. In C++, it's called std string, hopefully. The solution is really easy. A type is, again, just a name with an associative array from technology to the actual implementation type in the given language. So if we, for instance, wanted to create a password string of a given size, because we know what hash functions we are using and how big the hash is going to be, we can simply say on the D side, it's the string. On the MySQL side, it's a var of 128 characters. And this, again, allows us then in the code generation to use the appropriate types for the appropriate technology, which we have defined here. Now we get into the generating. Generator is just some class that gets passed the world. So it has everything it needs to know, or it has everything there is to know about the software system. And right now, there's the GraphViz generator and the MySQL generator, because I ran out of time to implement the vibe.d and Angular generator. Anyway, you then just call generate, and you generate stuff. So the GraphViz generator from the model I presented here for the system context basically creates me this. I have a user that is using our awesome software system, which in turn is using our hardware. And you can see here the description, what the user is actually doing with the software system. And if you remember the aggregation or the dependencies, the dependency was not actually just linked to the software system, but to the front-end controller. But anyway, as we don't really care about the details right now, we just generate the picture in such a way that it points to the software system itself. Then going one step further, we actually see that the user is using the front end, and the front end is then using HTTPS to connect to the server, which there's actually a database inside, but we didn't really care about that at the top level, but now we start to care a little bit, and we can sort of see how we always like pinch in and to see more details. Then if we take a look in the software system and actually down to the class level, we see our actually two classes and one additional class there. So we have the user, which is on the MySQL side is using the long type, the text, like the text actually twice, and on the D type it's like long lowercase and string and string. So we can actually see how we can generate from one model all these details. And interesting here, we also see the appropriate association or aggregation or composition actually between the different types. So this allows us then to generate the MySQL create table statements from what we have described at some point. So looking at that, we see this. We create an address with an ID, which is a primary key. Actually, there's a mistake, should probably also be auto-increment. We have a user, which has its ID, which is also auto-increment. And it also is generating the tables for the relationships between the different classes we have created. So in order to show that there's a dependency or there's a connection between the address and the user, we have to create a table containing the foreign key, like the user ID as a foreign key, and also the address ID as a foreign key. And we have to do all the scaffolding on cascade update and such. And additionally, we had this, whoops, wrong direction. We had this composition between the postal address and the address, which I didn't show on creating, but I think you get the idea. And therefore, we can also create the composition table, which is basically saying delete this postal address or delete the postal code if the connected address gets deleted. So we can also now generate MySQL out of it. Now the question you're probably asking yourself is, what can we actually generate? So first of all, we can generate diagrams at different levels. You've seen that. I guess you all have a fair understanding on how to do that. We can also generate database schema. We have seen that right now. But what we can also create is, like probably all of you have heard of PHP MySQL admin or myadmin, which is basically PHP software that allows you to administrate your database. And we have all the information about our database and how it connects. So there's nothing that stops us from creating a simple Vibe project with all that, do all the scaffolding, do all the layouting with the diet templates, and just generate a standalone Vibe implementation that talks to our database and displays us a PHP myadmin clone. So that's just stupid work we have to do. Also, writing code that accesses the database can be generated. We know how the data in the database is laid out. We know how the structs or classes on the D side look. So generating the source code that, for a given technology, writes us the function that gets the data out of the database and fills our structs on the D side is trivial. It's just work. We have to put once into the generator and then just use and be happy for all eternity, basically. Also, like, I had this, like, as shown before, dstructtotypescript was nice, but now we just write a generator for TypeScript, for D, for Java, for .NET, for whatever, and we can simply use that to generate the appropriate implementation from our meta model here. We can also create server skeletons. So when we see that there are different controllers in it, we can basically generate the folder structure and create the interfaces to it. So we just have to do the actual implementation of the APIs we want to provide. So, but I mean, at some point we actually have to do work, and as long as we can't generate business logic some way, I mean, that's where we have to start. Also, the front end is basically also just a library with classes, at least for Angular. So, or actually for most things, so we can also generate that. Right now, GraphViz is mostly done. That was like the thing I wanted to show because it's nice to show. MySQL is getting there. It's not really that difficult to figure out how to do composition between classes, as long as you don't do cycles, because cycles are really bad, even in MySQL. And from there, I want to go to Vibe and Angular 2, because like AngularJS, the Angular 1 version, is sort of dying out probably in the next couple of years, and Angular 2 is like the new awesome thing. And it's actually written directly in TypeScript, so that makes life a little bit easier. And Vibe, of course, because Vibe is just awesome with D and helps us not to type so much. So now you were probably surprised that we started with beating on D or saying that JavaScript and HTML are awesome. Then we were a little bit sad that dstructtotypescript was not really what we wanted to do, and right now I sort of hope that you sort of have this feeling here. And that actually concludes my presentation. So And as I was a little bit fast, just kill me now if you think Agile is cool, or ask questions that are hopefully a little bit more nice. Yeah?
I really like generators, so that's cool stuff and it's awesome, so thank you for that. From my experience, the biggest problem with generators is what you said, generating the skeletons, because then you have, that's a place where you do the actual work and you have to fit it in. So you talked about your generating interfaces. I would also expect you are generating a module containing this interface, or maybe a class skeleton, and then a programmer would add some code. And if you rerun your generation, then you have a problem, because you do the new generation and you already have some stuff. Do you have a solution for it? Because there are many tools which are great at generating some code, but they don't solve this problem, and then they are useless if you have started to work on it.
So my approach to that would be that you're only generating interfaces or abstract classes. You then subtype in your real implementation. Because if you start, or if you try to mix generated with non-generated code, as you said, that explodes in your face really quickly. So you have to be sort of strict and force your developers to adhere to that convention that you don't modify the generated files. And the thing is, then if you change the model and regenerate the interfaces, and maybe even change the functions that are available, remove functions or add functions, then you will get a compile time error saying you have missed this function, or this function doesn't exist anymore, or you have to implement that function. Yeah, but I mean, that's the way I think forward there.
Thanks.
Sure. Yeah.
Are we now going to see a D on Rails from you?
Come again?
Are we now going to see D on Rails from you?
Yeah, a colleague of me asked me the same thing, and maybe. I mean, yeah, Ruby on Rails is an awesome example. It basically provides you a nice skeleton to get started. But then at the long run, it sort of isn't as good anymore, because you have to use Ruby instead of D. And yeah, I can't go to RubyConf now, right? Yeah, but definitely this would be an awesome project to do, and isn't really that much work, and also sort of gives everybody a fair understanding on what to do if they come to a project using this. But I mean, this not only works for single-page applications. This basically works for all applications. If you think you're going to build a GTK application, well, please. Or if you think you're going to build a console-only application, sure, why not? I mean, you're not restricted to separating your software system in front-end and back-end or something. You can just have one software system and then use this tool to describe how your data is laid out, or how your system overall layout is structured. In the front.
Have you considered, instead of having statements to basically build your model, to just have your model in D and then put attributes on it, like this is the world, this is a person, that type of thing?
I don't really follow.
So
rephrase?
Yeah, annotations. Sorry, not attributes.
Ah, okay. So you mean user-defined annotations?
Yeah, so you say, this is my world, this is, and then you use that to generate the other non-D stuff.
I didn't, but nice idea, yeah. I expected a lot more questions here, I have to say. So either you all don't care or you like it. I mean...